go.
All righty. Good afternoon, everybody. My name is Jimmy Ray. This is another episode of Containers from the Couch. Today, I have with me Emin Alemdar, and we're going to be talking about the external secrets provider. Welcome, Emin.
Hello everyone. Welcome to the session.
So let's go ahead and give a brief introduction of what the external secrets operator is.
Yeah.
And for that, we'll bring up, you have a few slides to show us briefly.
Yeah. Thank you. So it's basically managing secrets from a centralized location in a cloud-native way. So before going into that, let me introduce myself. So my name is Emin Alemdar. I'm a cloud-native engineer at Container Solutions. And also I'm a community builder, AWS community builder in containers category. And also I'm a HashiCorp ambassador as well. So let's start with a question we always ask every day: is everything secure? From start, from the kernel itself to the user's authentication, and also network rules, our data, and how we can secure all the parts. And the answer is with the help of the third-party products, of course. And that there are so many great tools out there for almost every part we need to secure. Also, there are some native configurations in Kubernetes allow us to use the platform more securely. But we all know security can fail. There are some challenges. For example, complexity is the enemy of security, and also secret management as well. And secret management can quickly get complex. So the challenge number 2 would be there are multiple teams managing their own secrets in different environments and different ways. And that leads up to larger attack surface, secret sprawl, and lack of management or control over the environment. And the final challenge is integration configuration. It's increased complexity and also increase the attack surface as well. So let's say you have multiple teams, they're using multiple secrets, maybe they're using multiple secrets providers, external secrets providers, and it can get quite complex and you can lose control. So let's focus on secrets management. So we all have sensitive data like login credentials, API keys, certificates, all of that. And leaked secrets can cause serious damage to the organization. And there are some great tools out there for storing and managing our secrets from a centralized location, like AWS Secrets Manager or HashiCorp Vault or some other providers as well.
So let's let me ask a question here real quick.
Yeah.
Obviously, one of the drivers behind this is not storing secrets into in your applications or your source code for that matter.
Yeah.
Obviously, there's a lot of tools out there now that will actually strip that stuff out of your source code and will prevent things from happening there. It's actually a best practice, right, espoused by the 12-factor app methodology to not store your secrets alongside your code and your application. So what's one of the drivers here, right?
Yeah, definitely. You don't store your secret data in your code. You store it in a centralized location where you can audit the access. You can have control over the access with authentication and authorization methods. You can have a secret rotation. You can have integration with third-party application. That's why there's a secret management ecosystem out there with wide variety of tools, actually. But the problem with that is when you're looking at multi-service, multi-environment setup in Kubernetes, how are you going to distribute those secrets securely? For example, how are you going to consume the secret in app, which is not a best practice, or with a sidecar container, or with a controller, actually? because there are so many secrets to manage. There are multiple databases. There are multiple certificates we use for our applications, etc., etc. And it's becoming harder to handle the rotation of those secrets again. So the solution is external secrets operator is a Kubernetes operator, just born from the idea of having to manage all the secrets from Kubernetes itself, with plain YAML files, Kubernetes YAML definitions, and making the Kubernetes secrets object as a management object for all of our secret data. And it's there for secrets distribution between providers, and it's there for lifecycle management of those secrets, and there's a uniform configuration for authentication and authorization for different secret management providers. It's actually a beautiful open source project because there were multiple projects out there doing the same thing, and in one GitHub issue, discussion started about merging all those projects together in one project, and then ESO was born out of that. When we look at the architecture, it's basically operator controller pattern in Kubernetes. So we have a desired state, we have an actual state, current state, and there's a reconciliation loop in between, and it constantly observe the current state, and if desired state is not matching with the current state, it adjusts the object custom resource to be able to match the desired state. Actually,
So,
yeah.
with the external secrets provider or external secrets operator, I should say, it works with multiple providers. So I could conceivably plumb multiple providers into my my single cluster, correct?
Yeah, definitely.
At the same time, right? So
Yeah,
I could also, let's say, pull down secrets from one provider and push them up to another provider if I wanted to. Is that
definitely,
possible? Okay.
definitely. Yeah,
Okay. That's
that's
interesting.
possible. Yeah, in my demo, we'll see an example of that. Actually,
Okay.
I'll pull a secret from a provider and push the same secret to a different provider. Actually, so an operator in Kubernetes is an application-specific controller, as you already know, and these operators are software extensions to Kubernetes, and that make use of the custom resources to manage applications and their components. So we have some custom resource definitions, custom resources in external secrets operator as well. These are the main ones: secret store and external secret resources. Secret store specifies how to access the secret provider, how to authenticate to the provider. An external secret resource specifies what to fetch from that secret store, secret management provider. Of course, there are cluster versions available for cluster-wide access, like cluster secret store and cluster external secrets. The default ones are namespace resources. So if you're using multiple namespaces for separation, you'll need to have either multiple secret stores or external secret resources defined in your cluster, or you can use cluster secret store or cluster external secrets.
I would imagine for isolation purposes, I would imagine that most of the use cases are secret stores within specific isolated namespaces.
Definitely. For example, in this example scenario, let's say we have a shared AWS account, and we are using AWS Secrets Manager, and we have secrets prefixed with A and B and and cluster. There's a cluster admin that manages the secret store and secrets manager, and secret store credentials can only access only the tenant secrets, and developers can create and access secrets as needed. It improves the self-service again, and also, as you can see, developers below can't really access the secret store objects, so they don't have any access to secrets manager, or they don't have any control over the secrets management provider. The cluster admin manages those, but the developers can manage external secrets objects by creating the required custom resource in this example scenario. That way, we improve both self-service and also the separation between teams within a Kubernetes cluster. We talked about supported providers also. As you can see, there are known providers and there are some unknown, maybe uncommon providers as well, like Senhasegura, as you can see. Of course, this is a community-wide project. People can also contribute to the project from the GitHub page. They can add their providers if they want to, and we try to maintain some of the main providers, but we also encourage the community to contribute to the project and maybe add their providers to the project as well. And last but not least, ESO is now a CNCF Sandbox project. It's in the CNCF landscape, so if you want to contribute to a CNCF project, you're always welcome.
So I did notice that I think I noticed this, one of the providers that you all support in this project, I want to say is K8s.
Yeah.
So is that a new support for your project, or has it been there for a while?
I think some people in the community manages that provider.
Okay.
We don't have we don't manage all the providers within the project. Some people just want to add their providers, add their secret management providers to the project, and they're always welcome into the project. Yeah, there are some community maintained secrets management providers in the project right now. Yeah.
Okay.
Yeah. So let's move on to the demo then. So,
all right.
Yeah. This
is going to be a live demo then?
Yeah. Let's hope. I have given some sacrifices to demo gods, but let's see. So right. This is the demo architecture. So I have an EKS cluster, and I'll pull a secret from AWS parameter store, some parameter store, and then I'll push the same secret to AWS Secrets Manager. So let me open up my terminal. I hope you can see this. So I have created a GitHub repository for just for this demonstration. I've created my EKS cluster with Terraform, of course. I've used EKS blueprints for Terraform, and I also have an installation script for the installation of ESO as well. So as you can see, I have all the necessary resources in the external secrets namespace. It is now deployed. We have our deployments, we have our secrets, and I have created, by the way, I'll be using IAM roles for service accounts to authenticate with AWS. So I've created the necessary permissions, and you can find those in the GitHub repository as well in the installation script. But I have to say this, it's a powerful policy, so you shouldn't use it in production environments because it gives much more.
So you could scale it down, is what you're saying.
Yeah, you can narrow it down.
So this URSA role, this IAM role for service accounts, this role, it is, you defined it already and it's in there, but it's called when you say, here's the auth Z jot that I want to use to be able to do these secrets management, operations in the provider in AWS.
Yeah.
Okay.
Yeah, definitely. I have created the service account in the default namespace, and I've given the permissions to the service accounts. I haven't created any custom resources yet. Let's create those together. So I have some files in the folder. Let's first create the parameter store.
So when you say custom resources, this is like a secret store you're creating, right?
Yeah, definitely. Yeah.
So not a Kubernetes custom resource definition.
Yeah, it's actually a CRD, Kubernetes
It's
CRD.
created in the background. Okay.
Yeah. The type. Let's see this custom resources as well. So we have multiple custom resources like generating access tokens, cluster external secrets, cluster secret stores, ECR authentication tokens. We can generate ECR authentication tokens as well. There are some password generators, and I'm using this one right now. This custom resource definition. Let's see the file as well. Here's parameter store one. As you can see, this is a custom secret store, and I'm using this service account I've shown for authenticating with the parameter store service. And let's see if it's created. There you go. It's valid. We have the read-write capability, and it's ready. So right now, we don't have any secrets or any external secrets resource.
Okay. So
in our default namespace right
so when we talk about the service account being used here, this service account is actually annotated with the role that you created, and then
Yes.
Ursa takes over to give the JOT, the Web Identity Federation there. So generally, we see this being used when you add it to a pod or you add it to a deployment. But in this particular instance, you're not, right? You're just adding it to this secret store, and then it'll be used in the background.
Yes, you are correct.
All right.
So the whole point of external secrets operator is it's right now when I create an external secret resource, it'll authenticate with the secret store. And it'll fetch the secret. It requires secret from there, and it'll automatically create a Kubernetes secret object in the background for me, and then I can use that secret, that newly created Kubernetes secret, in my deployment definitions or pods definitions.
Okay.
So basically, ESO allows us to use native Kubernetes secrets objects rather than creating a volume, rather than creating a sidecar container. We're just using the Kubernetes secrets object. And I think personally, it's the easiest way to manage secrets from Kubernetes with the default Kubernetes secrets objects. Of course, you just need to think about encrypting those secrets, because when you create a Kubernetes secrets object, it'll store those secrets in etcd. Of course, it's going to be base 64 encoded format. But if a person can access to that etcd, they can basically decode those data from there. So you need to think about encryption as well, but ESO makes it
That's
easy.
a cluster. That would be a cluster setting.
Yeah.
So I mean, so you could turn on EKS envelope encryption. It would encrypt, at data at rest, basically, your secrets. However, the encryption and decryption is kind of a transparent data encryption. It takes place transparently to you. You'd actually have to go into the CloudTrail logs, I think, to actually see the encryption and decryption happening. So if you have rights to read that secret, you be able to decrypt it as well. So it's not it's not a client side encryption as much as it is a data at rest server side encryption.
Yeah, definitely. I'm just ESO is just trying to give an option to manage your secrets with the default Kubernetes secrets
Yeah.
object.
Yeah. And then are these opaque secrets when they're created for you, maybe marked immutable? Is that something that's done by default, or how's that work?
It's just creating an opaque secret.
Okay.
Yeah, let's create one. Yeah.
Okay. Yeah, that'd
So
be great.
yeah, let's see the file first. I have this external secrets.yaml. We have the secret store reference here, and the target is going to be the secret Kubernetes secrets object that will be created when I create this custom resource. And it's going to fetch the secret.password data in the parameter store. I created parameter store parameter before the session as well. So let's create this. Yep. So it's now created. Let's see the resource first. The new resource. And as you can see, its status is secret synced. So that means we have a new secret, new Kubernetes secret object, opaque type. And let's see the data. Yeah. Path. Data, password, right? And let's decode it as well. Oh, it's not working. Let's just do that. Yeah. Let's run this. As you can see, it fetched the data. It's containers from the couch. Let's check if
Oh, there you go. Yeah, cool.
Let's see if it's the correct one. Let's go to the parameter store. I have this parameter created before the session. As you can see, it's containers from the couch. That's the parameter we've get.
Okay.
Yeah. So another.
So the workflow here, just so I understand it, is you install the external secrets operator, then you went in there and installed an external secret store.
Yeah.
And then you pulled down a secret, basically syncing that secret. And in so doing, it created a local in your namespace Kubernetes secret for you.
Yes, definitely. Then I can now move on and use that newly created Kubernetes secret object in my deployment or pod or application.
Yeah, I mean, you could use it. I guess you could use it as a an image pool secret, maybe.
Yeah,
you could use it as a mapped volume in your pods, whatever.
Yeah, whatever you want. Of course, you can add a refresh interval to the configuration as well. So it basically checks the external secret provider. For example, let's say you have a refresh interval like set to 15 minutes, and it'll check the external secret provider every 15 minutes. And if you update the data, in the external secrets provider, it'll automatically fetch the newly created secret, but you can manually revoke this as well. You can manually just update the secrets with just one command. Again. So I have another resource. Let me just show that file as well, called PreSecrets.yaml. As you can see that there is this refresh interval parameter. You can add this to the external secret resource as well. So it's going to push the secret to the AWS Secrets Manager. It's going to push the newly created this secret, as you can see, in the default namespace, and it's again will create a secret, the secret key password, and the remote key is going to be ESO - containers from the couch. Let's create this resource as well. There we go. Let's check the resources. Third, let's see. Oh, I know the error. I have to create a secret store for secrets manager as well, right?
Oh, yeah, absolutely.
Yeah.
You have a place for it to come back to, right?
Yeah. Let me just create that again. AWS Secrets Manager. It uses the same authentication method. It uses the same IAM roles for
Okay.
service accounts, etc. So I can show the file again. It's not going to be that much different, but as you can see, I've changed the service from parameter store to secrets manager. I've used the same service accounts, same roles, same permissions. So if it's created now, yeah, it's valid. I have read-write capabilities. So let me again try to create this push secret resource. And change, oh, it's there. Let's see. Okay, it's now synced, as you can see. Let's go to the AWS console again. Let's see if it's created or not. You know, double check everything. As you can see, it's now created. Newly created secret. And the beautiful thing with the push secret feature, it automatically adds a tag to the newly created resources, like managed by external secrets. So you can easily know what resources, what secrets are created by ESO by looking at these tags, you know.
So at the same time, if we're looking at the screen right now, can I, with the push secret resource, can I enable the rotation for this individual secret, or is that something I would have to do in the console or API?
It's now disabled by default, but the push secret feature is a new feature. I'm not really sure about
Okay.
that rotation, but I can double check that
Oh,
later.
yeah. I think so. From a use case perspective, if I have a secret up here that is, in Secrets Manager that is set up for a specific rotation.
Yeah.
On the Kubernetes side, when I create the secret resources, I just want to make sure that my refresh cycle is, I guess, smaller than,
Yeah.
so that I'm always assured that I'm going to get a fresh secret.
Of course, definitely. Yeah. So let's go back to the terminal, and lastly, let's double check if the data is pushed correctly, right? So when I look at this, of course, I'm going to fetch the binary from here. Where's the copy? Yeah, there it is. And of course, let's
I got a double quote there.
Yeah. And let's again. Why it's not working? I'm having a problem with this.
That's because we're doing it live.
Yeah. Let's see if this works now. Let's just go there. Yeah, there it is. It's complete from the couch. Yeah. So as you can see, we've just fetched the secret from SSM parameter store and just we push that newly created Kubernetes secrets to AWS Secrets Manager.
Oh,
So yeah,
so you see that as a typical use case where I would pull from one secret store and push to another. Trying to understand the idea behind the push.
Yeah. You may want to migrate from one secret management provider to another. So that's one use case for push secret feature. Or let's say you were not using any secret management provider prior to that, and you can install and push all the secrets that you are using right now within your Kubernetes cluster, and benefit from the great features of the secret management provider by pushing all those Kubernetes secrets again. And also in the recent releases, you can also generate secrets with ESO as well. Like I showed you, you can create ECR tokens, you can create custom passwords or fake passwords, etc., from ESO as well. So yeah, these are the main use cases for push secrets. Yeah, in general. Yeah. Yeah, I think. Yeah, I think that's all for the demo part. I haven't installed any other secret management providers to showcase some scenarios, but there are tons of different options you can use. But the main idea is just managing secrets in Kubernetes from a centralized location. And having the being able to have that separation between teams and between it's against secret sprawl. It reduces the attack surface, and it only distributes the secrets securely. Encrypting data in transit actually.
So let's talk a little bit about other solutions out there. Like for instance, the secret store CSI driver is. How does this? Can you give me your idea of how this differs from that solution? What do you see the pros and cons?
With the CSI driver, you need to create a volume and you need to manage the volume itself as well. And from my perspective, it adds another layer of management burden on our shoulders. But when you compare it to the external secrets, you just need to manage a Kubernetes secrets object. That's as much as easier as it gets.
Okay.
Yeah.
And then from a namespace isolation perspective, I look at it when I'm creating the external secret, I can tell it what IAM role I want to reference, via that service account. So each namespace, or for that matter, could I have multiple? I could have multiple service accounts in the namespace as well. But at a minimum, I've got a namespace level isolation for permissions here.
Yeah, definitely. You can have multiple service accounts. You can have multiple secret stores, and in multiple different namespaces. So that gives you the flexibility of managing, all of that, different access methods. But at the same time, you have a unified, configuration for all of the access. And authentication. You just, for example, for EKS, you just create one role and attach that role and annotate the service account and attach that role to a service account. And basically, you create this authentication method. By doing that, you're not sharing any AWS access keys or secret
Mhm.
access keys. It's all secure in this manner. Yeah.
Okay. All right. So, where do you see ESO moving? What is the direction, or do you have any insight into the roadmap for?
Yeah. So we are really excited about the GA release. It's coming. I can't give you an exact date for that, but of course the GA is coming. So after the release 0.7, we've introduced PreSecrets and secrets generation. So basically, you will be able to manage the whole life cycle of a secret from Kubernetes with ESO. You'll be able to create secrets and push that secret and pull that secret. All of that life cycle from just managing some YAML files. By doing that, you won't have to push any secret data to your GitOps workflow or Git repository. You'll just have to manage the YAML files, and which is kind of exciting. You'll have that centralized management overall, all of your environments, and also we're now in CNCF Sandbox, but we want to go up to the ladder as well to incubating, maybe one day to the graduated level as well. And we are working with some great people within the community, and if anyone wants to contribute to the project, you're all welcome. By the way, I can share these QR codes, one for the project repository, and we are also in the Kubernetes Slack workspace, and you can reach out to us from Kubernetes Slack workspace. We have a channel there. All the maintainers and the community members are there. If you want to reach out and ask any questions, you can just go ahead and do that by
So your demo you did today, is that the link?
No, this is the project repo.
Yeah, but
actually.
in the comments that we share internally, there's a link.
Yeah.
Is that the demo stuff that you want?
Yeah, that's the demo. That's the demo setup I've done.
Okay.
I've showed.
And I can share that.
Yeah. Just make sure. Make sure. Don't use this policy, IAM policy, in your production environment.
Oh no, this is a
non-production. It's too powerful.
It's a non-production demo.
Yeah. It's powerful because it's just for demo purposes,
Okay.
Yeah. But of course, if you want to try, if you want to test it out, you can just go ahead and use this setup. Yeah. If I go back to here, maybe people want to scan the QR codes for these links. You can always, like I said, reach out and contribute to the project, or if you have any questions, you can just reach out to us as well.
And then here's the link for the actual project, right? This is the external secrets, operator project.
Yep, definitely.
Okay.
Yeah. Are there any questions? We can have a Q&A session.
Yeah, I'm looking. I don't see a lot of questions coming in.
Yeah.
So I think that might be it. Well, unless I see any other questions here, I mean, I really appreciate you coming on, Emin.
Of course.
This has been a live demo that went off with only a few issues that you were able to fix pretty quickly. So that's always good.
Yeah.
So
I always forget to apply some YAML files.
It happens to the best of us. It happens more than I would like to admit. But yeah.
Definitely. Thank you so much for having me.
Yeah, you're welcome. Thank you for coming here and showing us how to use this. And I'm sure we've shared the links, so I'm sure
Yeah.
you'll see some additional traffic.
Brilliant. Thank you. Thank you so much.
Thank you.